All right, so hello, good morning, everyone. We'll be discussing the LeetCode weekly contest solution for today. So, the date when I'm recording this video is 31st of March and the time is 11:18 a.m. The contest that we'll be solving today is weekly contest number 391. Giving a brief overview of the contest as we usually do. The first three problems were pretty simple. But the final problem was something which only if you know the formula for that, it would have been an easy problem. Else, it was difficult to solve that problem within the contest duration hours if you do not know the formula for that. All right. So let's get started with the discussion. Okay. Weekly contest number 391. We had four questions. This was the marking scheme 3, 4, 5, 7. Okay. So let's get started. Okay. Weekly contest number 391. Okay. So yeah, let's see that. Okay. Mm, wait a minute. All right. So an integer divisible by the sum of its digits is said to be a Harshad number. Okay. You're given an integer x, return the sum of the digits of x if x is a Harshad number, else return minus 1. Okay. So what they are asking here is that we have been given a number. All right. We need to get the sum of the digits of that number and we need to check if that sum of digits is divisible by that number. Or you can say the number is divisible by that sum of the digits. If it is, then you return the sum of the digits, else you return minus 1. So this happens to be a pretty simple problem. Okay. Uh, all right, let me just firstly let's go through the approach quickly and then I'll code it on spot. Okay. So if we have a number say n, so I think everyone is aware of the fact how do you take the sum of the digits of a number. You initialize a variable, okay. You run a while loop while this value is greater than 0. You'll do sum plus equals to n modulus 10, okay. That's it. And all you need to check is if n modulus 10, sorry, n modulus sum, if this is equals to 0, you return m sum, else you return minus 1. Okay, this is the complete code. The complexity is the number of digits of n. So you can take this as a constant time complexity and a constant space complexity. Okay, so this was the easiest problem of the question of the contest as usual. I hope everyone would have solved this, but let me just quickly code this for you. Okay, so ठीक है, for integer n is equals to x, n is greater than, sorry, not 10, greater than 0, and n slash equal 10. So you do sum plus equals n modulus 10 at every step. You return it like this. X modulus m is equals to 0. If it is, then you return sum, else you return minus 1. All right. Let's just run this code. Hopefully this should get accepted. Okay, so this is working. If you'll submit it, it'll get accepted. All right. Okay. So this finishes the first problem. Let's move on to the second one. Okay. Let's see what we have here. We have been given two integers, number of bottles and number of exchanges. So number of bottles represents the number of full bottles that you initially have. In one operation, you can do one of the following operations, okay? Drink any number of water bottles, turning them into empty bottles, okay? So in one operation, I can drink any number of filled up bottle of full water bottles. Okay, that is the first operation. Exchange the num exchange number of empty bottles with one full water bottle. Okay, then increase the num exchange by one. Okay, so what they are saying is that if say we have some num exchange, so I exchange that many number of empty bottles with one complete filled up bottle, and I increment the value of num exchange after that operation. Okay, note that you cannot exchange multiple batches of empty bottles for the same value of num exchange. Okay, that's pretty evident from the second operation only, that whenever I perform an exchange, I need to increment the value of my exchange variable, else I cannot do that exchange for the same variable for multiple operations. Okay, so I need to return the maximum number of water bottles I can drink. Okay, let's see the constraints for this question as well. That would be very helpful. Okay, so the constraints are very small. Okay, so you can say go for the brute force solution for this. Okay, and of course this is going to be the most optimal as well. So let's say if I have some number of bottles NB and some variable exchange. Okay, so at every step, ideally what I'll do is, if my number of bottles is greater than equal to E, okay, I will try to drink E number of bottles at every step. Okay, so I drink, say, I store the number of this total bottles I have drank in the variable D. So I'll increment this variable by E. Okay. Then I'll change my number of bottles minus equals to E, because this many number of bottles I have exchanged, and I need to increment this variable as well. Okay. Why I'm doing this? This is the most ideal operation I'll be doing optimally. Okay, firstly, I drink E number of bottles, so that is the maximum number of bottles I can drink. Okay, I cannot drink more than this. All right, at every step. So I drink this number of bottles, I exchange these many number of bottles, and I replace it with the one filled up bottle. Okay, so here I'm subtracting the exchange bottles, and here I'm adding that new bottle. Okay, and after this, make sure that you increment the E variable as well. Okay, so till this condition is true, okay, this condition, I need to perform all these operations. Okay, say whenever I come out of this loop, what will be the condition? That the exchange variable is greater than the number of bottles. That means I cannot exchange the bottles further. So what operation can I do? I At the end I can just drink this many number of bottles. So I'll just drink this many number of bottles, and this is the maximum number of bottles I drink. I just return this value. Okay, very simple. All right, because for till the time this number of bottles is greater than the exchange variable, greater than equal to the exchange variable, I'll try to keep on having more and more bottles. Okay, but when the condition reaches that the exchange variable is greater than the number of bottles, that means I cannot exchange the bottles now, and the last operation I can perform is to drink the current number of bottles, all of them. So I'll just drink all those bottles and I'll be done. Okay, so this is the approach for it. Complexity, you can say, for this again would be somewhere around what are we doing? We are incrementing E variable every time. Okay, so you can take it as say max value of E or number of bottles, something like this. Okay, but the values are very small, 100 kind of, so you can roughly it would be somewhere around this number O of n 100 ka cube, or the space complexity is O of 1 because we are not using any additional complexity for storing any variables, storing anything in the arrays or data structures like that. Okay, so the space complexity is O of 1. Let's go through the code for this quickly. Okay, so I initialize my total number of bottles which I have drunk till now as TOT. Okay, while this condition B is greater than equal to E. B is the number of bottles and E is the exchange. So while this condition holds true, I'll add E number of bottles to my total, subtract this number E from B, increment B, increment T. And when I come out of the loop, I need to add B to the final answer as well. Okay, so I just return the total variable and this will get accepted. Okay, so this was again a pretty simple question. All right. So let's move on to the next one. Okay. You're given a binary array nums. Okay. Binary array, I hope everyone's aware of. The arrays which only contain zeros and ones are called binary arrays. Okay. We call a subarray alternating if no two adjacent elements in the subarray have the same value. Okay, so a particular subarray is alternating if no two adjacent values are same. Okay, so it means like there are no cases for 1 1 or 0 0 appearing one after the other consecutively. So it's always like 0 1 0 1 0 1. Okay, so those are alternating subarrays. I need to return the number of alternating subarrays in nums. Okay, so let's move on to the case. All right. Okay. Acha, the constraints are again very important for this question. So the constraints are 10 power 5. Okay, that means you need to go for a O of n or an O of n log n kind of solution. So that is why I believe constraints are very important because it gives us an idea as to what kind of operation we can perform. Okay, so now I know that I need to perform an O of n log n kind of thing. This seems highly unlikely because binary search ka I do not have any cases here. So that means I need to go for a O of n kind of solution. Okay. Now try to visualize this. Let's say if I have not this, no, एक minute. Where's the rubber? You know. Okay. So say if I have a case like this, 1 1 1 0 1 0. Okay. So this is the subarray which is not alternating. Okay, I need to just discard this thing. Okay, this subarray is contributing 3 to my final answer as 3 single subarrays. Okay, apart from this there is no contribution from this. Okay, so what I can do is I can just remove this and I can count the subarrays for the rest of them. Now keep that in mind whenever you are selecting this thing. The starting and the ending element will also contribute to the answer here. Okay, so it's just that you need to ignore this thing, okay? And these four will be your subarrays, okay? Now let's see how many subarrays they can contribute, okay? So the subarrays which this will contribute is 0 1 0 1, 1 0 1, 0 1, and 1. These are the four subarrays that this particular subarray is contributing, okay? That means the size of the subarray. So whatever subarray I have, it will contribute n to the final answer. Okay, keep that in mind. All right, that's it. That's it. That's all we need to check. Okay, so what I'll do here is that I'll start iterating from the zero index. Okay, okay. At every step, the result, I'll initialize the result with 1. Okay, because this is for the first element as a single. So I'll start from 1. I'll go till the end or whatever you want to call it, n or end. Okay, I'll do I plus plus. I'll check for the ith and the I minus 1th element if they are same or not. Okay, all right, let's go to the next page. यहाँ पे बहुत खिचड़ मुचड़ हो रही है. All right, so I'll write a for loop. I'll start from 1. I'll go till n. I'll do I plus plus. Okay, I'll check for the consecutive elements. Okay, if these are same. Okay, if these are same, that means I need to break my size here. Okay, we had two variables, that is result and size is the longest consecutive length of alternating subarray. Okay, so as long as I get a alternating subarray, I'll increment this variable, else I'll change it to 1 again. So if these two values at any instant are same, that means मेरा loop break हो रहा है. So I need to change my size variable to 1. Okay, so I'll change my size variable to 1, else I'll do size plus 1. Okay, this is what I have to do. This is size. It's I think some problem with my laptop today. That is why the writing's way too bad as compared to the YAMS. Okay, so these are the two cases. All right. Now I just need to add size to my answer at every step. Okay. So this is what we'll be doing. Okay. So this will give me what I'm having here is that till the ith index, how many total subarrays I have. This is what I'm counting at every step. And when I reach the end, that is n minus 1. So this will automatically give me the total number of subarrays starting from the 0th index till the n minus 1th index. I come out of the loop and I return the size. Okay. Sorry, res, not size. Okay. I return the res variable and this is all I need to do. Okay, so complexity we had discussed already that it's O of n and space complexity is O of 1. All right. So let's just see the code for this quickly. Okay. I initialize my result variable. I initialize my size variable. Okay. I write a for loop. Okay. At every step, I'm comparing the two consecutive elements. If they are same, I change my size variable to 1. Else I change it to size plus 1. That is, I increment the value and I add the size value to the result at every step. And after coming out of the loop, I return the result variable. Simple as that. Okay. So the code seems pretty simple, and even the problem I would say was more on the easier side. Okay. So let's move on to the final question. Okay. The good one, I would say. Okay. Let's read this. You're given a zero index array points representing integer coordinates of some points on a 2D plane. Okay. So we have a 2D array. Okay, and every element of this 2D array is a point on the XY plane. Okay, the distance between these is 2 points are defined as Manhattan distance. So I hope everyone's aware of what Manhattan distance is. Manhattan distance is simply, if you want to see this, you can see this from this reference. Absolute value difference of the x coordinate plus absolute value difference of the y coordinates. Okay. Return the minimum possible value of max distance between any 2 points by removing exactly 1 point. Okay. So I need to return the minimum maximum value. Okay. I need to minimize the maximum value of distance between any 2 points if I remove 1 point. Okay. Now, the brute force approach for this is very simple, that every step you remove 1 point and you check the maximum distance between all the points and you just return the maximum, you just minimize that maximum value and you return that value. But if you go for the constraints, that is 10 power 5, OMG, that means that we need to go for an O of n solution. All right, we cannot go for an n square solution here. Okay, now this is very evident. If I'm going for an O of n solution, I need to pre-compute the distance between the points somehow. Okay, that is very important, that I cannot, because I cannot just go for this, that I remove 1 point from 0 till n in between. Let's say I remove the ith point, and for the rest of the points, I calculate the distance like this. K is equal like this, and distance I update the max value, something like, I cannot do this. Okay, because the complexity would be not acceptable for this question, this kind of complexity. Okay, so what do I need to do here? Okay, I need to pre-compute the distances between the points. Okay, this is what I need to do. Now, how you do that, this is the main gist of the question, that if you know this formula, you will be easy, it will be easy for you, which is given in the hint. So I won't be writing this down. Okay, you can take it up from the hints. Okay, notice that the Manhattan distance between 2 points xi yi and xj yj is given by this formula. Okay, so the absolute value is the actual formula, but say if I do not want to use the absolute value function, then how should I take that distance? So you take the maximum value of these four this things values. Okay, now, oops, sorry. Now, what you need to check is that in these four values, if I replace my point with this value, okay, let's say if I have the point xi comma yi and I replace this point with xi minus yi, xi plus yi, okay, and I do this with all the points. So this formula would come down to be this value, okay, which is max value of xi minus min value of xi comma max value of yi minus min value of yi. Okay, so say if I have 2 points. Okay, let's say if I have, oh wait a minute, problem 4. Okay, so I have 2 points xi yi xj yj. I replace these points with xi minus yi xi plus yi. Similarly, this becomes xj minus yj, xj plus yj. Okay. If this is my, these are my 2 points. So the distance between them is gonna be the max value of the x coordinate minus min value of x coordinate, comma, max of yc minus min of yc. Okay. This is the final, what you can call as the distance. Okay. My final Manhattan distance. You can check this. Okay. All right. Max value of both these things. This is your final answer. All right. So if I just take the for 2 points, okay, for 2 points, any 2 points, okay, and this xc is the updated value, not the previous value. So this formula, if you know, then the question becomes very simple for you. Okay, that means all you need to do is you need to replace all the points like this, the way I have done in step number 2. Okay, this one, just do this kind of replacement for all these points, push them to a set, and at every step you just take out any one of them. Okay, you just take out any one of the pointers, and for the rest of them you just take the maximum value of x coordinate minus the minimum value of x coordinate, maximum y coordinate minus minimum y coordinate. That is all you need to take, because in a set all the things are already in a sorted order. Okay, so this is the main crux for this question. Again, if you knew this approach, then it would have been a very easy problem for you, else it is a difficult one. Okay, and that is why this problem has a 7 pointer this time. Okay, so the complexity, yeah, the complexity, again I'll discuss the code as well, but the complexity would be n log n, and the space complexity would be O of n for storing the elements in a set data structure. So let's go through the code quickly. Oops, the screen's hanging a lot today. All right, so we have the size. We prepared two sets. Okay. As I said, I need to just change the variables xi. You can do plus or minus, minus or plus. It's up to you. It won't really make a difference. So I insert the updated x value in S and the updated y value in D. And I'm storing the index as well. Why we are storing, we'll show that. Okay. I initialize the answer variable as int max because I need to minimize this value every time. Okay. All right. So I just take out one particular value from 0 to n. Okay. So this is the value I have taken. Let's say I'm removing the ith value from the original array. Okay, original array say I'm removing the ith value. I'll erase this from S. I'll erase it from D. I'll pick up the starting and ending values from X, that is the minimum and the maximum, and same for D. Okay, I'll check for the distance as shown in the formula here. Okay, this formula, this is what I'm writing here now, as done in this formula. I'll update the answer variable. I'll insert the value. Okay, when I remove it, it's very important that for the next step I insert it back again. So when I update my answer, I need to insert it back again. Simple. And I read to return the answer variable. Done. Okay. This question is also done. So if you submit this, this will get accepted. And yeah, this ends the discussion for this contest. Okay. Let me just give a final review for the contest from my side. Okay, how the contest was. The first problem was again 1 out of 5. The second was 2 out of 5. Third was also 2 out of 5. And the fourth problem was 4 out of 5. Okay, I won't say 5 out of 5 because it was not much about the logic. It was more about whether you knew the technique or not. So this is the kind of problem for which you'll find a number of articles on the internet, that how to update this Manhattan distance in O of n kind of a thing. So you can find some articles on the internet. Okay, and feel free to share those articles in the chat section if you find any such articles. Okay, I'd like to see what you guys go through as materials for your preparation from your end rather than what just I'm sharing. Okay, so this. ends the discussion. And please feel free to give your feedbacks in the chat section. Like, subscribe, share as much as you can with your friends so that I can make more such videos. Lately, I've been getting less amount of time to record videos because of a lot of hectic schedule in office. So, yeah. Till that time, stay safe, keep practicing, and have a wonderful weekend ahead. We'll meet up in the next contest. Cheers and bye bye, everyone. Happy learning.